anytime I give you a no calculator quiz or test with logs, if I ask you to evaluate the log, then it should be something you could do in your head. Like think about the exponents of that particular base. But in the calculator portion, I can give you logs that like we don't know. So like log, the example that we're going to do here in a little bit is log base 2 of 12. So like if I'm just thinking about log base 2 of 12, 2 to what exponent equals 12, I don't know exactly. So I wouldn't put this on no calculator. If I did, you'd have to leave it alone. Can you estimate what the exponent would be?
Is it 2 radical 3?
No.
Oh, no.
Okay, why do you say 3.5-ish? 2 cubed is 8, 2 to the 4th is 16, 12 is kind of right in the middle of those two, right? So we're thinking somewhere like 3.5. So this formula, the change of base formula, allows you to actually find it. Now notice that on the left it says log base a of x, so that's any base. And on the right in the formula it just says log x divided by log a. When I don't put a base there, what is the base? 10. That's called the common log. You could understand why 10 is the common log because you've seen scientific notation in a lot of different ways. 10 is a really common base for a power. Okay? So this one uses your common log button. As long as you do log of the thing you're taking the log of divided by the log of the base, the common log, then you'll get the same answer. But it doesn't have to be common log. You could also do natural log of x divided by natural log of a. As long as you do the log of both parts, like the same base log, you'll get the same answer. So let's evaluate and see if Sierra was right, 3.5-ish. If we were doing log base 2 of 12, we would do with common log, the log of 12 divided by the log of 2. Or you could try the natural log of 12 divided by the natural log of 2. Those should come out to be the same answers. I don't care which one you try in your calculator. Type it in. Make sure you have the muscle memory to change the base. Can you do it? And notice I wrote up there like I closed my parentheses. 3.58, and I'm going to get one more number. 5. So it's very common with logs and exponential equations, like when you solve to go up to the nearest thousand, just so that you have like a slightly more accurate answer. There are usually decimals that don't repeat. Okay, so that kind of makes sense, right? That's almost exactly what, well, that is exactly what Sierra told us, 3.5-ish. It's perfect, okay? All right, so that's the answer. Now, I am going to show you so you can investigate to see if your calculator has a way to change the base. But I do want to say before I do that, I expect everybody to know this change of base formula. So if I ask you a question about the change of base formula, you understand what it is. So like, don't rely too heavily on your calculator. Know that you can also do the change of base formula. Let's see. Did anybody, out of curiosity last night, figure out for themselves before I spill the beans? How do you do a log with the different base in your calculator? Anybody Google that? Sierra?
You go to math and then you go down to the little thing and it says
Okay, if you haven't done a lot of like playing around with your calculator, it's worthwhile to like hit a few buttons, right, and figure out what's out there. If you click math, which is right underneath your alpha button, it takes you to this menu, and there's different columns for the menus, like things that you can do with it. But like notice here, like if you ever want to do a cube root or an nth root, that's in the math thing. Sierra talked about scrolling down, but you can also scroll up, which the only reason I would want to scroll up is log base is kind of at the end of the list, right? So then I can go choose log base. And then I have that set up. So now, Andrew, if you want to go back and check your homework assignments, you could do that in the y equals menu if your calculator has it. Now, if your calculator doesn't show log base in the math menu, it's possible that you may have an older operating system, like if you have one of your siblings' calculators, so it might not have it. You can check. There's a catalog in the calculator. If you do second 0, you can run through the list of all the things in the catalog and see if it shows up. Like it should be alphabetical, so it would be down by the log. But my guess is if it's not in the math menu, you probably don't have it. Well, that's fine. Use the change base formula. No big deal. Someone also told me if you do alpha window, you get this beautiful menu of things you can do, and log base is at number 5, so then you can choose that one. I haven't investigated on the Casios, but if the Casios don't have it, it'd be just like if you have an older version of the TI, you're just doing change base. Okay, now let's put our calculators away because we're going to do the rest of these without a calculator. Properties of logs. Now, I'm hoping that when you talked about the properties of logs last year, that your teacher mentioned that these are really just rewriting properties of exponents, because logs are exponents, right? The answer to a log is an exponent. So before I get down into the product quotient power property for logs, I'm going to review those 3 properties in exponents. So the power property in exponents, what if I gave you something like x to the a times x to the b, the product of powers? What do you do with your exponents? You add them. That's x to the a plus b. Or what if I give you a quotient of powers? Then you subtract. Excellent. And the other one is the power. What if you do a power of a power? Multiply. Oops, I always write a right there, but I mean to write x. X to the a times b. Okay, so we're not reinventing the properties. We're just rewriting them as the logs are now our exponents. So these should look familiar, although we might use different letters than the Algebra 2 textbook. Suppose I'm doing the log base a of a product. So products are things that are multiplied. Well, when I do product property, I should add exponents. So in the log properties, this turns into the log base a of u plus the log base a of v. So we separate out the products so they're each their own individual exponent, log base b of u, log base b of v, or sorry, log base a of u, log base a of v, and you put a plus in between them. Could you write out the quotient power, or sorry, quotient property for logs? Yeah, use the same letters. Log base a of u divided by v, and knowing what we know about the quotient property of exponents, that's going to turn into the log base a of u minus the log base a of v. If you have more things in the numerator, like let's say you had u times z over v, then you would have a product in the numerator and you would just subtract your log in the denominator. If you had more things in the denominator, so let's say you had u divided by vy, then every log that was down in the denominator, you would have a minus sign in front of it, so you could do like a minus log base a of y in the back. So any log that has a negative in front of it, I assume is going into the denominator of a fraction. Okay. And the last one is the power property. This is going to look like log base a of u raised to the n. Now remember, in the power of a power property for exponents, you multiply your exponents. So we want to multiply exponents in this property. One of our exponents is very easy to see. It's the exponent n, right? And we should multiply it with the other exponent, which is the log base a of u. So its property looks like n times the log base a of u. A lot of times when I talk about that in Algebra 2, we talk about dropping the exponent. So the exponent drops right in front of the log, becomes the coefficient to the log. And then you're going to do some practice with your group here in a little bit, but you can go either way on these properties. If you go from left to right, this is called expanding a log. And if you go from right to left, we call it condensing the log. So you're going to see those in your directions. Expand, condense. Okay. If I'm being asked to expand something, what I do is I kind of survey what's happening behind the log. Do I have stuff that's multiplied? Do I have stuff that's divided? Or do I have a power? I don't ever worry about expanding plus or minus, because I have no property for expanding plus or minus. Okay. So I look for things on the left and change them to be things on the right. And then if I'm told in my directions that I'm supposed to be condensing, I should see like 2 logs that are added together. I can put them back as 1 log of a product. Or 2 logs that are being subtracted, put them back as 1 log of a quotient. Remember, any of the logs that have negatives, those values go back in the denominator. Okay. The power property, I usually do this one last in expanding, but first in condensing. Okay? And you'll just have to be mindful about like what does your exponent apply to? Does it apply to the whole thing, so I need a group of parentheses? Or is it only applying to like one value, one term, and then I only put it in front of that one log? So those are things that you and your groups are going to work on when you do the examples. Okay, so the rest of the time you're going to be working on your own properties of exponents.